And okay, let's turn back to female here. And how about, we just use race variable? Well, it's going to run through. It's going to run through, okay? But this is wrong because remember how race is coded: 1 for white, 2 for black, and 3 for other. That means somehow for some value for this race variable, other is triple the value of white. Does not make any sense. So although here the regression runs through, but the results are completely wrong. In this case, we have to use what? We have to use dummy variable. So in this case, as was discussed previously, for K category nominal variables, okay, we can create K dummy variables corresponding to each value category, but we have to use K minus 1 dummy variables because here we have 3 categories for race. In this case, we have to use 2 dummies. In this case, black and other. So for black, just to remind you that for this black dummy variable, only black respondents are coded as 1. White and other are coded as what? As 0. For this other dummy variable, right? Only members of other racial category are coded as 1. All other racial categories, including black and white, are coded as what? As 0. And in this case, I omitted a third dummy variable, white. Mathematically and statistically speaking, the omitted category, the omitted dummy variable representing whichever value category is going to be used as the reference category, meaning the category that's going to be compared to. So let's run this regression and then let me interpret the results. So in this case, it runs through, okay, pretty nicely. And the results I can tell you make substantive tense and mathematical statistically meaningful, okay? So how to interpret the results for black and other? I already interpret the results for female, right? Holding all the variables constant, on average, females have, having, in this case, actually, the coefficient has changed, right? In this case, let me do it again, okay? So holding all other variables constant, including age and race variables, females on average have 1.06813 days of feeling not so well with their mental health. Then males do. Okay? So how about black in this case? Well, in this case, we're going to say, well, holding all other variables constant, including the gender, female variable, and age. We're going to say, well, blacks on average have 1.88214 days fewer, okay, than whites do. So be very careful about the reference category because white dummy is dropped, okay? And we're comparing all the race dummies used in the regression with that reference category, in this case, whites. So we say, well, on average, blacks have 1.88214 days fewer than whites do. About what? About feeling not so well in their mental health. So the interpretation wording is a little bit awkward, but it gives us very clear idea about the comparison and the number, okay? Same thing for other. So the coefficient is in relation to the status of whites, not blacks, okay? So here we're gonna say, well, holding all other variables constant, including age and gender, we're gonna say, well, members from the other racial category have 0.65073 more day of feeling what not so well in their mental health, then what? Again, whites do. Whites do. People say, well, why we always compare with whites? Can we compare with blacks? Because I just want to use black as reference category. We can do that. In this case, we go back because of regression, and we replace black with white. So note that here we have dummies for two categories, right? Categories that are coded as 1 and these two dummies, and otherwise coded as 0. And in this case, I omitted what? Black. So black is going to be used as the reference category. So let's run this regression and see the results. Now we can compare. So in this case, for white, we're going to say, well, holding all other variables constant, whites on average have 1.88214 more days of feeling not so well in their mental health than blacks do, or compare with what? Blacks. And let's look at the results here and here. Here, when black compare with white, it's what? 1.88 fewer days. Reversely, we can say, well, whites have 1.88 more days, right? Is that correct? That's exactly here. For other, okay, for other, we're going to say, well, holding all other variables constant, members from the other racial category have 2.53 more days on average. Okay, here on average, either, I should have said beforehand, on average, members from the other racial category have 2.53287 more days of feeling not so well in their mental health than what? Blacks do. Blacks do. Okay. Okay. Here people say, well, I don't like, this very tedious, kind of coding. Okay. Yes. In this case, instead of using very kind of tedious dummy coding and use dummy variables explicitly, we can use factorized, multi-category nominal variables. So if you remember, I already create this factorized race variable. Okay, so it's called race new. Okay, and let's see what happens. Okay, see, it runs through and it dropped one category. In this case, it dropped whites. Okay, and it automatically creates two dummy variables and with some variable labels, variable names to explicitly spell out the value category, because here in this label argument, while I was kind of factorizing this race variable, I put there, and they're used in the creation of variable names for the dummy variables when I use this factor variable race new. Okay, race new. Okay, so that's automatic. And people say, well, what's going to happen if I use all three dummy variables? Well, can you guess what's going to happen? Well, it's going to run through as if nothing strange or nothing, kind of surprising ever happened, but it made correction in the background. Okay, actually, it's going to drop the last dummy variable, okay, for race. And let's see if my guess is correct. And you see that? So other is dropped, because, as I told you before, right? For K category multi-category nominal level variables, that's pretty long name for that. So shall I say, I'll change to for K category nominal variables. We can and probably should create k dummy variables, okay, for each category, okay? One for each. Okay? But in regression analysis, we have to use k minus 1, and we have to drop one dummy. And the dropped one going to be used as what? The reference category and group for the dummy variables used in regression analysis to be compared to. Okay, this concludes my discussion, very brief introduction to the use of dummy variables. And in this case, I focus on OL's regression. So in interpretation, I just use the unit of this mental health variable. For binary regression models, for ordinal regression models, and for other categorical and limited response variable models, when we make comparisons, okay, we got to use the scale of the response variables. Sometimes it's going to be odds. Sometimes it's going to be what? Rate, etc. And we got to pay close attention to that. So this concludes my pretty brief introduction to dummy variables.